cache. Under that will be seeing cache, main memory, and secondary storage. So first of all, what is meant by memory? So memory, we know normally it is the storage. Okay, we can store the data. For that only the memory is used. How it is arranged, how these memories are arranged. So what are the use? All those things we are going to see in this topic. So the main memory, normally in computer memory, which is divided into two types. One is primary memory and another one is secondary memory. So again, this primary memory is divided into two types. One is RAM and another one is ROM. So RAM is a volatile memory and ROM is a non-volatile memory. So what is meant by volatile memory in the sense when the power is there means the content will be there. If the power is off means whatever the content we have typed it will get lost. So that is the meaning of that volatile. So RAM is volatile. Okay. So again it is divided into two types. One is SRAM and then DRAM. So SRAM is nothing but static RAM. DRAM is nothing but dynamic RAM. Again, this ROM, read-only memory, which is a non-volatile memory, is again divided into two types. One is PROM, that is programmable read-only memory. Erasable programmable read-only memory. Okay, so programmable read-only memory. Next is erasable programmable read-only memory. And then electrically erasable programmable read-only memory. So the short form they have written like PROM, EPROM, WPROM like that. So again this secondary memory where the secondary storage we having inbuilt in our CPU. So if we want we can add additionally also this hard disk which is represented using this HDD, that is hard disk, SSD, and then compact disk, CD, floppy disk, and then magnetic tape. So these are all the secondary memory. Okay, where we can store the data here. So what is meant by memory? So as I said previously, the memory is the most important element of a computing system. Because without it, a computer cannot perform any simple task. So normally the computer memory is of two basic types. One is primary memory, that is our RAM and ROM. And next is our secondary memory, that is hard drive, CD, etc. like that. So random access memory, that is our RAM, is a primary volatile memory. And read-only memory, that is our ROM, is primary non-volatile memory. Okay, so this is about the memory is concerned. Okay, so we are going to see in detail. So which we saw previously with the tablet column, we are going to see with the explanation now. RAM. So random access memory. So it is also called as read-write memory or the main memory or primary memory. We can having other names also. So the programs and the data that the CPU requires during the execution of the program are stored in this memory only. So it is a volatile memory as the data loses when the power gets turned off. And again, this RAM is further classified into two types. One is our SRAM, that is our static random access memory, and then DRAM, that is our dynamic random access memory. So SRAM and DRAM. So it is very fast memory system, which is very fast. This SRAM and DRAM is a very fast memory system, and it can be achieved by our using our SRAM chips. And it is very costly because it is very costly, as it is more expensive. It is impractical to build a large main memory using this SRAM chips. So the only alternative to use instead of this SRAM, what chips we can use means we can use a DRAM. A large main memory, I can use this DRAM, but the speed comparing to DRAM, SRAM speed will be more, but it is very costly. That is the thing. In memory system, a small section of SRAM is added along with the main memory, which is referred to as cache memory. So as it is very costly only, what we are making is in the main memory, we are adding only that small section of this SRAM alone, along with this main memory. That only we are telling as what? Our cache memory. So what is the difference between these DRAM and the SRAM? So DRAM is concerned, it is constructed of, this memory is constructed of tiny capacitors. Tiny capacitor that leak electricity. But SRAM is concerned, it constructed of circuits which is similar to our D flip-flops. And DRAM which requires a recharge. Every few milliseconds I need to recharge to maintain its data. But SRAM is concerned, it holds its content as long as the power is available. So whatever the content I'm just storing, that will be what's stored as long the power is available. And DRAM is very not that much expensive, so it is inexpensive when we are comparing to SRAM. And the SRAM is expensive, it is costly only. And here DRAM is lower than the SRAM, but the SRAM is faster than the DRAM. And here it can store many bits per chip, but SRAM cannot store many bits per chip. And DRAM which uses only less power, okay, consumes only less power. And here it consumes more power. And under DRAM it generates less heat. SRAM generates more heat. And this DRAM is used mainly for the main memory purpose. And this SRAM is used for the cache memory purpose. So that is a major difference between this DRAM and then SRAM. So next is our ROM, that is our read-only memory. We are going to see in detail. So this read-only memory will be storing some crucial information which is important to operate our system. Okay, for example, if I'm just turning on my computer, what happens? It is taking time for booting to get our OS file. So that type of program, okay, the booting programs, all those things will be stored in this ROM only. And it is not volatile, and the power is off, the content will not get erased. It will be there only. Okay, so that is the meaning of this not volatile. The content will be there, it will not get erased even though the power is off. Always it retains its data. Then only whenever I'm just on my computer, it turns on and I could able to see all the things, whatever the edition, whatever the thing I want to use, that I can make. Okay, so only because of this booting. For this booting, I need some permanent storage. It should be stored in some place. Okay, so that place only we are telling as ROM. And it is used in embedded system or where the programming need no change. So in that place and all, this ROM is used. And it is used in calculators and peripheral devices. It is used. And this ROM is further classified into four types. One is ROM, and then ROM, that is programmable read-only memory, and then erasable programmable read-only memory, and then electrically erasable programmable read-only memory. So these are these four types under this ROM. So we are going to see in detail about this ROM. So that is programmable read-only memory. It can be programmed only by the user. So once we have programmed this ROM, what happens? The data and the instruction, whatever I have stored in this ROM, it cannot be changed. So that is the meaning of that. And EEPROM means it is a erasable programmable read-only memory. It can be reprogrammed. So already we have programmed, but if I want to reprogram again in that same place means, how I can reprogram means I need to erase the previous content. So how I can erase the previous content means by exposing that room to that UV light. That is our ultraviolet light. If we are exposing, what happens, the content will get erased and we can again reprogram it. Okay, so by erasing all the previous data, we can reprogram it. How we are erasing all the previous data means using this ultraviolet light. So next is our electrically erasable programmable read-only memory. So the data can be erased by applying the electric field. Okay, so in previous case, we are erasing the data using our ultraviolet light. But here in this electrically erasable programmable read-only memory, we are erasing the data by applying the electric field. And here there is no need of the ultraviolet light and all. And here we can erase any portions of the chips. If I don't want to erase previously all the data also, if I want to erase any small portion, that too we can do it. So what is the difference between this RAM and then ROM? So RAM is concerned, it's a temporary storage. And ROM is concerned, it's a permanent storage. For booting purpose and all, the data will get stored in this ROM only. And then here it stores the data in megabytes. And ROM here it stores the data in gigabytes. So it will be storing more when we are comparing to RAM. And it is volatile. When the power is off, all the data will get off. But whatever the data stored in RAM, when the power is off also, the data will not get erased because that is a basement, because all the important data are stored in this ROM only. For booting purpose, the programs and all will be stored in this ROM only. So we are calling this ROM is non-volatile. And here RAM is used in the normal operations. But ROM here is used for the startup process of a computer. And here RAM, the writing data is faster. And ROM is concerned, the writing the data is slower. So that's a major difference between this RAM and then ROM. So next is our cache, or cache memory. So the cache memory is a special, very high-speed memory. Mainly it is used to speed up the particular process. And it will synchronize with the high-speed CPU. And this cache memory is very much costlier than our main memory or disk memory. Because I'm using this SRAM. In previous cases, we know, right? So we saw we are using the SRAM chips in the cache memory. That's why it is very expensive and that will be very fast too. So our cache memory is an extremely fast memory type that acts as a buffer between our RAM and the CPU. And the cache memory is used to reduce the average time to access the data from the main memory. So the primary cache is always located on the processor chip. The cache will be very small and its accessing time is comparable to that of the processor register. So primary cache, when I concerned, it will be present in on the processor CPU chips itself. So that only they are telling. This primary cache is a fast and it will be very small cache memory. and it is present inside or close to our CPU chip. And then the secondary cache, then is our secondary cache. So primary cache, it is close to our CPU chip. When we are considering about the secondary cache is placed between the primary cache and the rest of the memory. And the secondary cache is a type of cache memory that is deployed and installed external to the primary or processor cache. And it is a fast data storage. And the access memory that works in addition to this primary cache. So only we are telling this secondary cache as an external cache. So if I want to, that only they have given here. So in addition to this primary cache, if I want more speed means I can have this secondary cache also, because it is a fast data storage as I said previously, and it works addition to this primary cache, making the work in more speed manner. So only as we are adding this additionally, we let the hierarchy are arranged. So here the memory hierarchy is an enhancement to organize the memory such that it can minimize the access time. Okay, so I'm just organizing the memory such that I can minimize the access time. I can minimize the access time by how I'm just minimizing the accessing time by organizing this memory that we need to know. So this is the memory hierarchy. So how I'm just arranging means I'm having this primary cache present in the CPU, and then followed by the secondary cache, and then the main memory, and then magnetic disk or magnetic tape for the secondary memory. So when I'm just going from top to bottom, the size increases. Okay, I'm just increasing the size. But when I'm just going from bottom to top, the speed increases and the cost increases. So when I'm comparing this primary cache to secondary cache, the primary cache speed and cost will be more when I'm comparing to secondary cache. The primary cache size is less when I'm comparing to this secondary cache. So that is the thing we need to know. And here secondary cache speed is more when I'm comparing to main memory. Or secondary cache cost is more when I'm comparing to main memory. Similar way here, main memory speed is more and cost is more when I'm comparing to magnetic disk or magnetic tape or secondary memory. So when it is going from top to bottom, it is increasing the size. When it is going from bottom to top, it is increasing the speed and the cost. So this is the main hierarchy. This is the main memory hierarchy over here. So see here, I'm just placing this cache memory here between the CPU and the primary memory, and after this secondary memory. So to speed up the process, I'm just storing the data in this cache memory. So what is the main memory communication with the secondary memory? How it is get communicated? So normally the CPU and cache memory, main memory, all those things are there means these magnetic tapes and magnetic disk or the secondary storage devices. So from here the data will be what retrieved by this input output processor. And from here the data will be retrieved from this by this main memory, and if some data to be stored, currently whatever the data I'm just executing, that will be stored in the cache memory to speed up the process. So that will be placed in the cache memory too. So the content, whatever the operation it's going to perform, so that will be communicating with the CPU where the processing will be takes place, and again the data will be stored in this magnetic tape or magnetic disk, that is in the secondary storage. So this is how the communication is happening between this main memory and the secondary memory. So what are the levels of hierarchy? So we having 2 level, 3 level, 4 level hierarchy. So how this means, normally the 2 level means I am having main memory and secondary memory. And here the instructions and the data can be fetched from the secondary memory to the main memory and main memory to the CPU. And again the data which is calculated, processed, that will be stored in the main memory and from here to secondary memory. So this is how the communication will be there. If I'm having 3 level means in addition to this 2 level, I'm just adding one another cache, external cache, having the instruction and data cache, I'm just adding over here to speed up my process. Again, same the instructions or data from this secondary memory to main memory and then to this cache and then to CPU. So like this, the communication is happening and then vice versa. So 4 level cache means addition to this 3 level, I'm having another one more cache. So 2 levels of cache are there. So 1, 2, 3, 4. So 4 level. 3 means 1, 2, 3. So 3 level. 2 level means 1, 2. So according to that memory, I'm just telling that levels. So memory technology. So memory technology is concerned how the internal organizations of the memory chips are placed. How these memory chips are organized. So that only there here. So these and all we are telling as a cells. Okay. So memory cells are usually organized in the form of an array. See here. So memory cells, how it is arranged in a form of an array, one after another. So see here, everything is arranged one after another. And what this capable means, each cell is capable of storing 1 bit of information. Each cell is capable of storing 1 bit of information. And each row of cell constitutes a memory word. Each row, it constitutes what? A memory word. And all the cells of the row, okay, all the cells, okay, how these cells are connected means to a common line. All the cells are connected to this common line. This common line only they are telling us a word line. So again, this word line is connected to this address decoder. So these memory cells are there, which will store, each cell will be storing one bit, and all these cells are connected to this word line, and this word line is connected to this address decoder. And the cells in each column, the cells in each column will be connected to the sense or write circuit. So all the cells are connected to this. How means by using this 2 bit lines. Using this 2 bit lines only, this everything will be connected to sensor write circuit. Again, the sensor write circuit is connected to the data input output lines. Chips. So again, I am repeating. So here the memory chip, memory cell we having, each cell will be storing one bit of information, and which is connected to this line which is called word line, and this word line is connected to this address decoder, and these are column wise, these cells are connected to this sensor write circuit, and this will be connected to this data input output lines. And then we having the control signals here. One is read and write, and then control signal, that is our chip select. Then write and then chip select. So this read and write and chip select are provided in addition to our address and data lines. As we having address and data lines, in addition to that, we having this read write and then chip select. So what it will do? So this read and write, what it will do means, this read and write input specifies the required operation, what it needs to perform. Read operation or write operation. So that thing this read and write will do. And this CS, that is our chip select, that will select the given chip. in a multi-chip memory system. That will select the given chip in what? In a multi-chip memory system. So this is about the control signal present in this memory technology. So in this read operation, during this read operation, what happens means the circuit sends or read the information stored in the cell selected by the word line. Circuit, what it means, sends the data what I want to read. That information will be stored in the cell. Okay, that information will be selected by this word line. What information to be read, and that information will be transmitted to the data output lines. So what I want to read, so the word line will be getting that, and that will be transmitted to the data output lines. And during the write operation, what happens? So during the write operation, the sense or write circuit will be receiving the input information. The sensor write circuit, what it will do means it will be receiving the input information, and then it will be storing it in the cells of the selected word. So during the read operation, the word line will be selecting the particular data from this particular cell, and it will be sending to the data output lines. And during the write operation, the sensor write circuit, what it will do? It will receive the input information, and that information will be stored in the cells which is selected by that word line. So this is the thing you need to know about this read and then write. So next is our external connection. What are the external connection we having in that memory technology? So we having a memory circuit which stores 128 bits. Okay, so this is a memory circuit which is storing 128 bits of information, and it requires 16 external connections. It requires, in addition to this 128 bits, it requires 16 external connection. That is 14 external connection for address, data and control lines. And it also needs 2 lines for power supply and external connections. So the memory circuit stores this 128 bits, and it requires 16 external connection. But this 14 external connection for address, data and control lines, and it also needs 2 lines for power supply and then external connections. So this is about this external connections, which is present in that memory technology. So next is our cache memory. So the hit rate, what is meant by that hit rate we need to know. So hit rate nothing but what? The percentage of access where the processor finds a code or the data word it needs in the cache memory. Okay, so in what time it is finding that particular data in this cache memory, that accessing time, that only we are telling as a hit rate. So normally the hit rate should be greater than 90%. So how to calculate this hit rate? We have in the formula. So they will be asking in the GATE exam. So this is the number of hits means, this is the number of bus cycles means, what will be the hit rate? So you need to know this formula. What is the percentage? So you need to tell by substituting in this formula. So what is the formula? Hit rate equal to number of hits divided by total number of bus cycles into 100%. Into 100 in the sense whatever the output I'm just getting, calculating that will be in form of percentage because I'm just multiplying by 100. So again repeating the formula. So hit rate equal to number of hits divided by total number of bus cycles into 100. So that is about this hit rate in the cache memory. So next is our cache coherency. So cache coherency means in single CPU system, 2 copies of same data. 2 copies of same data. So one in cache memory and another in main memory. So may become different. Okay, so in single CPU system, two copies of same data, so one in cache memory and another in main memory. So may become what different. So the data inconsistency will occur. So this data inconsistency only we are calling as a cache coherence problem. Okay. So cache mapping function. So what is meant by this cache mapping function? So usually the cache memory can store a reasonable number of blocks. At any given time, we can store any reasonable number of blocks. But this number is actually small when we are comparing to the total number of blocks in the main memory. So the cache memory normally will be storing the reasonable number of blocks at a given time. But this number will also be what? Small. This number will be small when I am just comparing to the total number of blocks in the main memory. So the correspondence between the main memory blocks and those in the cache is specified by a mapping function. Is specified by a mapping function. So the correspondence between this main memory blocks and those in the cache only we are specifying by this mapping function. So there are three main mapping techniques of it. So one is direct mapping, associative mapping, and then set associative mapping. So these are the three main mapping techniques. Okay. So again repeating, the cache memory can store a reasonable number of blocks at any given time, but this number is small when I am comparing to the total number of blocks in the main memory. So this correspondence between this main memory block and those in a cache which is specified by this mapping function. So there are three main mapping techniques. One is direct mapping, associative, and then set associative mapping. So direct mapping. In direct mapping, so in main memory, we'll be having the set of data. So how this data is fetched from this main memory to this cache. So we having the blocks, okay, data in this main memory. So we are telling from block 0 to 256. Okay, we having this certain set of blocks till 256, 257. So that we are starting from 0 means till 256. So it will be present in the main memory. So what I want to execute, so that will be fetched from this main memory to this cache. And here in this cache, each block will be represented with a tag. Okay, so by having this tag, we can know which block I need to execute. So by having this tag only, we are just taking that set of blocks from this cache. So like this, we having separate tag for each block. But here in the cache memory, we'll be having only 128 bits. So starting from this block 0 to block 127, we are representing from block 0 to block 127. So how this is represented using this bits means tag, block, word. So tag that is 5 bits and block for 7 bits and word for 4 bits. So like this we are representing. So this will be present in this direct mapping. So directly first 127 data will be coming. So after fetching next 127. So like that it will be there. So directly the data will be what? Fetched from here to here. So that is the meaning of this direct mapping. So each block from the main memory has only one possible location in the cache organization. Okay. Each location will be having only one location in this cache. So that only they are telling. Each block from the main memory has only one. Each block from the main memory will be having only one location in the cache organization. And whenever one of the main memory blocks like 0, 128, because that on the start first is 0, next to 120, next after that 127, whatever the data. So like that it goes on. So like that it goes on there in the main memory. So whenever one of the main memory blocks like 0, 128, 256 is loaded in the cache, it is stored in the cache block 0. So after having this block and all this block 0, block 128, all those things and all will be stored in the block 0 of this cache. And block 1, in this block 1 of the cache, what data will be stored means cache is 0, as I said previously, it will be storing cache 0, sorry, block 0 and block 128, block 256, all those blocks from the main memory, it will be storing in the cache. That is block 0 of the cache. And for block 1 of the cache, again, block 1 of the cache, I'll be having a block 1, block 159 and block 257 of that particular main memory. Block 1, block 129, block 257, all those data from this main memory that will be stored in the block 1 of this cache. Okay. So here the address is divided into these 3 fields. These are the 3 fields we saw. One is tag field and another one is block and then word. Okay, so in this address we are dividing into these 3 fields and it is represented like 574 respective to this tag block word field. And the lower order 4-bit, select one of the 16 words in the block. So lower order 4-bit only, okay, lower order 4-bit only will be selecting one of the 16 words in that particular block, it will be selecting. And this field only we are telling as a word field. So lower order 4 bits only will be selecting one of the 16 words in the block. So this field only we are telling as a word field. Okay, so this field I am just telling. Word field. This is the lower order, which is having how many bits? 4 bits. So 4 bit, that what it will do, that 4 bits what it will do? It will select one of the 16 words in the block. From the block, it will be storing only, selecting only the one of that 16 words in the block. And this field is for what? Word field. Which field I am talking? I am talking about this field. And then the second field is our block field. And this block field which contains how many bits? It will be having 7 bits. And for what purpose the 7 bits is used? It is used to determine the cache position. Why this 7 bits means? I want to find out the cache position. Which block of the main memory should be stored in which block of the cache? I want to find out the position. So which is determining that position means our block field determining that position. So this block field only will find out the cache position in which block from the main memory must be stored. And then this is the higher order bit field, that is our tag field, which is having the 5 bits. So higher order 5 bits for what purpose means to identify which of the 32 blocks that are mapped into this cache. Which of the 32 blocks, which 32 blocks are mapped into this cache, this higher order 5 bits will be identified. And this field only we are telling as what? Tag field. The higher order 5 bits of the address. Okay, address or compared with the tag bits or compared with the tag bits associated with that cache location. Okay, so if they match means in that case, then that particular desired word is in that block of the cache. If it matches means, if there is no match it is finding means what happens means then the block containing that particular required word must first be read from the main memory. Then only it will be loading in the cache. So that is the thing here about this tag block and for having this technique. What happens means a main memory block can be placed into any cache block position. There is no fixed block and all. The memory address will be having the two fields. One is our low order, that is our 4-bit select one of the 16 words in a block. This field only we are telling as a word field. And the higher order, our 12 bits, which identify which of the 32 blocks that are mapped into the cache. This field is known as tag field. So this technique will give a complete freedom in choosing the cache location in which to place the memory block. So the cache has to replace the existing block. Only if the cache is full. So only if the cache is full, it needs to replace the existing block. So what is the drawback on this? Need to know the drawback. So it is necessary to compare the higher order bits of the address of the main memory with all that 128 tags. We need to compare, then only we can find out which block of main memory to be placed in which block of cache. So I need to compare all the higher order bits of that address of that main memory with that of the 128 tag, which is corresponding to each block, to determine whether a given block is in the cache. Then only that particular block data from the cache it will be fetching, and all that writing, everything, whatever the calculation I need to do, it will be performed. This is our thing. So our second one is our associative mapping. So in associative mapping, this only I told here. In associative mapping only, we saw previous thing what I have given the explanation. This part is belongs to this associative mapping. So in this associative mapping only, we having the two fields like tag and word field. One is a lower 4-bit and another is a higher 12-bit, which is placed in this main memory address. And here we having the main memory starting from the 0 to 4095. So how from starting from 0 to 4095 like this, the blocks are there in the main memory. And how it is fetched means same thing. But here in direct will be having this tag field. But here we are not having that extra tag field. We having only the two field. One is lower order 4-bit, which will be selecting one of the 16 words in that particular block. That is called as our word field. And then our higher order next field, that is our higher order field. So that will be 12 bits. Okay. Why means to identify which of the 32 blocks should be mapped into that cache. And this field only we are telling as a tag field here. Here I am having a tag and word. In direct I am having this block in addition. But here in associative mapping I am not having the block, only the tag and the word I am having. For tag it is 12 and for word it is 4. So this is how the memory from the particular main memory to the cache, how it is get blocked. So that only we are having here. So this is about what? Associative mapping. So third one is our set associative mapping. Set associative mapping in the sense what means here the blocks from this main memory will be sent to this cache. But here to set I am just having the pair. That pair only we are telling as a set. Okay, so I'm telling as a set. So tag this pair I'm just telling as set 0, and this again this two thing as a pair I'm telling as set 1. So like that I'm having 63 sets. Okay, 0 to 63. Okay, so pair it will be taking as a set. So only the name set associative mapping. So similar to our associative mapping, that instead of 12 bits in the tag, I am having 6 bits in the tag and 6 bits in the set and 4 bits in the word. Okay, so it is a lower order and then this is higher order and this one is a higher order. So this thing is actually present in this set associative mapping. What is meant by the latency? We need to know what is meant by latency. So latency is nothing but what? The amount of time it takes to transfer a word of data to or from the memory. So how much time it is taking to transfer the data? Okay, to the memory and from the memory. So that amount of time only we are telling as what? Latency. So what is meant by this bandwidth? So bandwidth is nothing but the number of bits or bytes that can be transferred in 1 second. Okay, so how many bits we can transfer in 1 second? So that number of bits only we are telling as what? Bandwidth. So this is about latency and then bandwidth. Okay, so like this, the questions will be asked based on this query, how it is arranged and what is cache, how this blocks from this main memory to cache, how the data will be get, that blocks, how it will identify, and then what is meant by this main memory, how the communication happening between this cache and main memory, and then between this primary memory to the secondary storage, why the secondary storage are used. So all those things we need to know. Okay, so this is about the thing over here. Okay, so this memory hierarchy. So under this only we'll be telling this cache, main memory, and then secondary storage over here. So the classifications we saw here, what is meant by memory, what is meant by RAM, the SRAM means what, DRAM means what is the difference between these two, and what is meant by ROM, and what are the types of ROM we having, what is the purpose of that, and what is meant by cache, and how it is organized, that memory, how it is organized, that memory hierarchy, and how the communication is happening between the main memory and the secondary memory, and what are the levels of hierarchy, and how this memory or this bits word line, how it is located, these memory cells which is holding each bit information, how the internal organizations of the memory chips are there. So that full memory technology, and then how that is arranged with control signals are there, like read, write, and shift select. So during the read operation, what happens? During the write operation, what happens? And what are the external connections we having? So 16 external connections we having, right? So 14 for address and data and control lines, and 2 for that chip select and read and write. Cache memory means what? How the heat rate can be calculated. For this, we need to know this formula. Number of hits by total number of bus cycles into 100. And then what is meant by cache coherency? Okay, so that inconsistency in the data, that where the cache coherence problem will occur. And what is meant by this cache mapping function? So we are having 3 mapping functions like direct, associative, set associative. So indirect, we saw 3 field like tag, block, word. So 4 bits for word field and 7 for block and 5 for tag. So then for associative is concerned, we having 2 field, 4 for word and 12 for tag. Okay, so this is for associative. And when set associative is considered in pairs of sets, each 2 tags in pairs of sets we are considering. So here tags hit word, so 664 we having in the main memory. According to that, it will be placed in the cache. So what is meant by latency? The amount of time it takes to transfer the word of data to and from the memory is termed as a latency. Bandwidth means what? It is a number of bits or bytes that can be transferred in 1 second. That only we are telling as a bandwidth. So these are things you need to know under this topic. And they will be asking questions how this blocks from the main memory to the cache, how it is happening. So like that and all the problems be asked. Okay, so do well. Okay, so apart from these thing, you browse many questions from the websites also, and prepare for your gate and do well. All the best to you. Okay. Thank you, ma'am. Thank you so much.